Oh, how you love boxes. Oh, boxes. Boxes in basic perspective. So if you think about X, Y, and Z used for the Cartesian coordinate system for 3D, you have the X for the horizontal, the Y for the vertical, and the Z for the depth, right? Now if you think about 1 point perspective, you have a horizon line which represents the eye line, and you would have the depth going back to a common vanishing point, like that. So if you had railroad tracks, right, you'd have your ties getting smaller as they go back, receding into the distance, diminished scale, right? But if you look at this like more box here, you'd have the X, or the horizontal, would stay constant. The Y, or the vertical, would stay constant. And it would only be the Z receding back into space. If you had 2 point perspective, you would have two vanishing points on the same horizontal line, right? Like that. So you'd have, because it's twisted, but basically you would have like, we'll call it X, we'll have the horizontal, say, going back to a vanishing point, and the Z continuing to go back to another vanishing point. So you have two vanishing points, right? But this vertical, or Y, stays constant. There's another type of perspective called 3 point perspective, where if you had like a really tall building, you could have it like recede as it gets farther away from you, or a really deep hole if it, as it converges, it got really far away from you. The key being it's converging, it gets really far away from you. So it's important to remember that linear perspective is not reality. It's just a device to help convey the idea of 3D space. So one of the most common errors that happen with 2 point perspective, the most common type of perspective to be used, is that when you have the vanishing points too close together on the horizontal line, you get this thing called forced perspective, where you get these really acute angles and it looks really weird. Sometimes it's used for effect, for like drawing cars or something to make it more dynamic, but usually it just looks strange, right? So when we're looking at like a box form, or a cube, as this is, the more useful thing, I think, is to think about consistency. What is parallel on the cube or on the box? So if you just think about which the parallel lines are, 1, 2, 3, 1, 2, 3, 1, 2, 3, and you just focus on identifying the parallel lines and trying to make sure they all play on the same team, maybe converging slightly, but mostly just keeping them parallel, the easier it'll be. So that's particularly useful for smaller objects, that aren't like giant things. Where people often run into problems is when you have situations like this, where the box has these parallel sides like there, and these two are close together. It's easy to keep track of, but the one that's farther away often gets away from the artist and starts doing its own thing and diverging, which starts to do pretty strange things. So when you're looking at this form, you want to think about, where are those parallel lines? So 1, 2, 3. Right? 1, 2, 3. And 1, 2, 3. All right, so even if it's not perfect, which in sketching things rarely are, the intention is what's important, and to always be trying to keep track of what's parallel and have them kind of work together, so you can have them either converge slightly, but not diverge, because then that just starts communicating something else.